I thought I'd start by telling you a little anecdote of something that happened to me about a year ago. I was boarding a flight to Buenos Aires and in New York to give a lecture. And I sat down in my seat, and next to me sat a young woman. We started talking. And it turned out that she had just obtained her degree from the University of Chicago, and she was working for a cloud-based education company. Now, I just started my own cloud-based education company, so I thought, I better find out what it is that she does. It turns out her company was making flashcards, these cards that have questions on one side and answers on the other, for smartphones. I had trouble not rolling my eyes. Now, it was about a month after the HILT Symposium here on campus. And for those of you who went to that HILT Symposium, a psychologist from the University of Washington in St. Louis, Ruddy Rödinger, gave a fascinating talk about flashcards and about studying with flashcards. He had done tests in which he had looked at the retention of Swahili words after students have one study session with flashcards. And he showed in an article that appeared in Science in 2010 that if you test students 1 week later, they only remember 35%. After 2 weeks, you can't even measure it anymore. So I thought, she ought to know this. Now, it turned out I downloaded this paper. It was on my iPad, so I bent over, grabbed my iPad, quickly pulled up the paper, which incidentally also has suggestions about how to improve retention and memory. And I gave her the iPad with the abstract on the screen. She looked at it for no more than 10 seconds and then handed the iPad back to me. And she looked me straight in the eyes. And she said, "But we only guarantee that they will pass the test." I had never thought about it that way. But it brought back a vivid memory. My daughter, was a student here. She graduated a few years ago, pre-med. And she would come home with me during the weekends, and on Monday morning, we'd drive back to campus. I'd be sitting in the driver's seat, she'd be sitting in the passenger seat. Flashcards. "Natalie, what are you doing with flashcards?" "I have to learn all these amino acids." I said, "I have an app for that." "Seriously, I do." "It's a great app." She says, "Yes, but we're not allowed to use the iPhone during our exams." So that made me realize that students, even with the best intentions, because my daughter and I spoke frequently about learning and about teaching and doing well in school, that even with the best of intentions, students' study habits are driven by the assessment. Those of you who have followed my career know that for 20 years I've been bashing the lecture as an outmoded approach to teaching that focuses mostly on information transfer. By the way, that is a picture of me teaching my pre-med course right here. No, it's actually B, but it's in this building right here, next door. It's a very old picture. It was taken BC, before computers, using the overhead projector. Well, today I'm going to argue that our approach to assessment, and including the one that I've been using until a few years ago, is equally focused on the regurgitation of memorized information and cookbook procedures. And therefore, instead of developing 21st century skills, assessment is really mostly focused on ranking and classifying. So here's what I'd like to do in the next half hour or so. I would like to first focus a little bit on the purposes of assessment. Why are we assessing? Then I'd like to discuss some problems I have personally identified, and it's really only the tip of the iceberg. And finally, I'd like to offer a few concrete ideas for improvement. Stellar transcript and end up not performing, and people who had no transcript or terrible transcripts and ended up being stellar. In fact, for this talk, I did something which I'd always wanted to do but never got to do. I decided to go back to data I'd obtained a long time ago and plot two metrics in the sense of evaluating students, then plot one versus the other. On the vertical is the final grade, which is based on the final exam. In that year, I was using a final exam, 2 midterms, and it was 80% of the grade. So, and the exams were purely textbook problems. That's on the vertical. On the horizontal is a very different metric, a 29-question test of students' understanding of the concept of force, tested purely by words. If you ask graduate students to solve, and faculty to solve the problem, they'll make 1 to 3 or 0 to 3 problems. According to the author of the test, and there's been a lot of research done on this test, anybody who scores 21 or lower is still an Aristotelian thinker, has really not understood the concept of force. But look at the distribution on the vertical. There are some students who ended up almost acing the test, and of course others who did very poorly, but there's a huge distribution. If we look at students who score at the highest level on the conceptual understanding, you still see a very broad distribution from a little over 60% to 100%. Let me draw your attention in particular to these two data points. Here's somebody on the left who is still an Aristotelian thinker, but I want to make the statement today that even assessment that claims to test problem-solving skills, and I think a lot of us do, I certainly did for many years without realizing this, do not really do so. And let me explain why. Let's first ask ourselves, what is a problem? What is a real problem? If you have a real problem, you know the outcome you want to obtain. The outcome is known. What is not known is how to get there. You have an interview in San Francisco. You head out to Logan Airport to take the last flight out to the West Coast. Your flight is canceled. You got a problem. The desired outcome is known, being in San Francisco. The question is, how do you get there? Any real problem fits that pattern. You're the CEO of a company. You've made new product in a certain category. Your goal is to make that product successful. The question is not making the product the outcome. The question is, how do you get there? You're an investment banker managing a big fund. The desired outcome is known, more money. The question is, how? So I would say most real problems we face in life fit that pattern of a known outcome with an unknown path to that outcome. Now, most textbook problems are very different because they ask, especially in the sciences, because they ask students to apply known procedures to find unknown answers. Cars driving along the road, and blah, 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 and so on. It hits a tree. What was the velocity of the car before it hit the tree? The student, in her mind, looks for a formula that gives velocity, then searches for the formula that has the appropriate unknowns, puts in the number, and gets the answer. Now, it may pay to briefly stop and think about the thinking skills, and I'd like to put up this little pyramid here, which is due to Benjamin Bloom, an American psychologist, who ordered these thinking skills from lower order at the bottom to higher order at the top. My claim is that a real problem test all the way up to the top of this pyramid, whereas most inauthentic problems test at the bottom. Let me give you a little example. Years ago, I was painting my living room on a Saturday morning, and I ran out of paint. I hopped into my car and drove to Harvard Square to buy some paint. You may know this hotel, I forgot, its name keeps changing. It was the Harvard Motor Lodge. I don't know what it is now. It has this parking lot underneath with 20 spots on one side, 20 on the other side. Until that morning, I had the practice of pulling in on one side. If there was no space empty, I'd pull out back into front of the Charles and then back in again, and then turn around and go and go and go until somebody freed up a spot. That Saturday morning, for a reason that I don't know, I decided to stay put, give up on the other 20 spots. And as I turned off the engine and waited, I thought, how long am I going to have to wait? And I thought to myself, can I estimate how long I have to wait? And I thought about it for a few minutes and came up with the answer, 3 minutes. And looked at my watch, and sure enough, 3 minutes later, somebody came up and freed up a spot. I felt so good. Now imagine we turn this into an exam problem. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? I think your students will go to the dean to complain. Because what does it require to answer this question? It requires making assumptions. It requires developing a model. It requires then applying that model to come up with an answer. So if we look at this pyramid that I showed before, it really requires skills all the way from the bottom to the top of the pyramid. Which of the things, of the requirements that are on there, do the students hate the most? Making assumptions. Why? Because you lose solid ground under the feet. So given that assumptions are the most terrifying to students on an exam, and I don't blame them, I'll get back to why that is, even though, let's face it, the ability to make correct assumptions is probably one of the most useful skills, no matter what type of job our students are eventually going to take. And the reason we're terrified about it is because of the uncertainty and because of the fact that we never get to train those muscles that help us make assumptions. So let's make the assumption. Just add one sentence. On average, people shop for 2 hours. 2 minutes is too short, 2 days is too long, so 2 hours is probably the right ballpark figure. You've maybe nibbled a little bit at the top of the pyramid, but it still is a pretty difficult problem because it requires students to develop a model that they've not seen before. It would be unfair. You know, I can't resist to tell you a little other anecdote. I'm going to get carried away with anecdotes here. But a few years ago, I was giving a talk at a university south of here in Connecticut. I won't name any names. And in the physics department about teaching. And after my talk, one of the faculty members came to me and he said, I've had something really strange happen in my course this year. He wanted to put he taught physics to engineers, and he wanted to put it into a real-world context. And in order to put it in a real-world context, he used baseball. I mean, there's a lot of physics in baseball, right? Trajectories of balls, collisions between balls and bats, runners running, you name it. So in class, he'd use examples from baseball. On the homework, he would put baseball problems. On the midterm examination, he'd put baseball problems. At the end of the year, he was preparing the final exam, and he realized he'd run out of baseball problems. So he put some football problems on the exam. Professor, complained the students, we have never done any football problems. You're laughing about it, but I think we should really be crying about it. Because, let's face it, unless you can transfer what you've learned in one context to another context, you have not really learned. Anyway, let's take this model that the students have never seen before out of the problem by putting it inside the statement. Assuming people leave at regularly spaced intervals, how long do you have to wait before somebody frees up a space? Well, Still, if I were to put this on an exam, even in that shape, people would say, why is Professor Mazur putting these silly parking lot problems on the exam? So instead, I'm going to take this problem and I'm going to turn it into a standard textbook problem. Here we are. Oh, by the way, with that last, putting the model in the problem, we've dropped 3 notches actually to applying and no longer evaluating, analyzing, creating. Okay, so let me turn this into a standard textbook problem. Here we are. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area where people are known to shop, on average, for 2 hours. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before somebody frees up a space? You say, isn't that the problem we started with? Yes. But somewhere in the book, there's this formula, colloquially known as the parking lot formula. T wait equals T shop divided by N spaces. And the students have memorized that equation, and all they need is a calculator. And all of a sudden, we drop down to the lowest level, remembering. I've exaggerated perhaps a little bit, but I think if you critically evaluate many back-of-the-chapter textbook problems, they fall precisely in this last category. Now, the thing is, computers can do this. And just as assembly line jobs have been eliminated by robots, so do I predict that computers will eliminate any job that requires information retrieval or procedural problem solving, because it can be done by computers. And therefore, we should really focus on what I like to call real problem solving. We have a problem, however, because as I alluded to before, real problem solving is erratic by nature. It's not that you have a straight path from the problem to the solution. You may try out one approach, it doesn't work. You may try out another approach, it doesn't work. In fact, I would say the road to any creative solution, to any innovation, is littered by failures. And unfortunately, because of the way we educate, students have become afraid of making mistakes. In a sense, our grading is incompatible with real problem solving because it penalizes students for making mistakes. They become risk averse instead of being encouraged to take risk. So let's now turn to the environment. Let me pull up a picture and ask you what that picture represents. I'm sure you instantly recognize this. And if this picture evokes any pleasant feelings, then I would like to talk to you at the end of this talk. What kind of feeling does it evoke as you look at that picture? I'm asking you. Stress? I beg your pardon? Sympathy. Work. There's another word I'm looking for. Anxiety. Okay, so we've got the stress and the anxiety out. What else? Frustration. Yeah. Isolation. Thank you very much. Look at these people. Cut off from each other. Cut off from any source of information. I'm sure you remember these moments, and they still apparently cause a lot of, bad feelings. Let me ask you a question. Have you ever, in your professional life, encountered a situation where you were cut off from any source of information and from other people? No. In real life, we work together. We can look up things whenever we want. There is nobody standing near my desk while I'm writing a paper on the research I do, saying, you're not allowed to look up the paper by your colleague at Yale. You should have known this by heart. It's not about remembering information. It's really about knowing how to use it. And of course, traditionally, assessment has been a high-stakes affair, culminating in the final exam. Students study for exams. Professors encourage students to study for exams. Now, unfortunately, high-stakes examinations promote cramming, and as we all know, cramming only stores information in short-term memory, and consequently, there's neither retention nor transfer. In a sense, examinations are the silent killer of educational innovation. I realized in that discussion on my flight to Buenos Aires that I'd overlooked assessment, and that no matter how innovative the approach to teaching, it's the assessment that drives students' behavior. Instead of studying for exams, they should really study for learning. And assessment should really be used as an opportunity to improve the learning. And in that respect, I think feedback, and we heard that as one of the purposes of assessment, is absolutely crucial. On the one hand, we have grades, which provide a measure of standing relative to others. On the other hand, assessment provides an opportunity for feedback, on reflection on what has been learned. I realized also that assessment produces a conflict. As teacher, I want to coach the students to be the best they can be. If I succeed in doing that, I want to give them all an A. But at the same time, I'm put in the position of being a judge. Imagine somebody who coaches, let's say, a figure skater, trains for the Olympics with the skater, and then all of a sudden at the Olympics is put in the position of judge. You'd have a serious conflict. In a sense, we face that conflict all the time in our classrooms. On the one hand, being the coach, on the other hand, being the judge. So how do we resolve that conflict? Well, we resolve that conflict by going to something like objectivity, by being, fair and reliable. But here's a real problem. If we go back to this pyramid, you can only judge the lowest order thinking skills objectively. In other words, in the name of objectivity, we resort to measuring something that ends up not being very meaningful to the careers of our students. Anyway, there are more problems like grade inflation and cheating, and I can probably fill a whole talk by just doing that, but I want to end by making some concrete suggestions and present 4 ways that might improve our assessment techniques. The first one is, let's mimic real life. It took me a long while to realize that cutting off students from information actually sends the wrong signal to them, because they have to memorize the information, which they will not need to do for their final exams. I made a slow transition. And first I gave them a sheet of formulas, and then I said the next year, bring in your own sheet, only to discover that some developed this microscopic way of writing. The whole textbook is on one page. Incidentally, those pages provide quite an insight into how students organize the information. Anyway, then the next year I thought, why don't they, if they can write the whole book on one page, why don't they just bring the book? So I told them, bring the book. The next year some students says, well, I prefer this book rather than the book that we use for the course. Can I bring that book? Sure, bring the book. And then another year, students said, oh, I'd like to bring my notes from the problem set. Can I bring those? Sure, why not bring them? In fact, you can bring anything you want except another living person. And a communication device. But then, and actually by doing that, I realized 2 things. One is you send a very strong message to students. It's not about retaining the information. It's about knowing how to use the information, which still requires the same knowledge as you would otherwise, but it frees you from memorizing it. But then I started assessing my students using the computer. And that posed another problem, because now all of a sudden students would be able to Google anything they want. And that's what made me realize that actually if you pose a question to which the answer can be Googled, it's not really an authentic assessment question. So I'm fine by that, because if we look again at this pyramid, what that does is it removes the bottom part of it. There is no remembering. There will still be remembering, because if you need to look up something fairly often, you remember it automatically. You remember it not because somebody made you remember it because you need to use that information. And in a sense, it lifts the entire exam. So rather than being easier, it becomes harder in the sense that it tests higher order thinking skills. So that's about cutting off information. I'm going to show you a little video clip from a class in Indonesia. It's in Bandung, Indonesia. And it's in Malay, so you won't be able to understand what they say. But I want you to look at the video and then tell me what activity the students are involved in and what the discipline is. So what's happening here? They grade papers written by their fellows, and they're having a lot of sadistic pleasure in doing that. I don't need to hear some more here.
Looking at exam solutions.
Looking at exam solutions. They are taking a quiz. They're doing an exam. They're actually taking an exam. Guess what field? Statistics. Have you ever seen people have this much fun in a statistics class? This whole exam centers around this little form, which is called an if-at form, instant feedback assessment technique. It comes from team-based learning. How many of you have heard about team-based learning? A few people. If you have never used team-based learning, look at teambasedlearning.org. It's really a fabulously interesting approach to teaching. But the assessment, called readiness assurance, involves a multiple choice exam. I know, this is not the ideal, but bear with me for just a second. And the first time that I became aware of this, I was at the University of Delaware. I was Phi Beta Kappa visiting scholar, and as Phi Beta Kappa visiting scholar, you have a 3-day program, and they shuttle you between different departments, and you observe some classes, and you teach a class. And on my schedule was this biochemistry class. I went to the class. It was 10 minutes early, so there were no students yet. And the instructor it was a class not like this. It was 5 round tables, each with 8 chairs. And the instructor was putting pieces of paper on the table, and I introduced myself, and he said, today we have an exam. And I thought, oh, there must have been a scheduling mistake. So I thought, shall I do some email outside? He said, no, I want you to participate in the exam. And I said, what's the exam about? Hemoglobin. I said, I don't know anything about hemoglobin. Anyway, before I could protest, students had come in. I was sitting at one of the tables. I got a multiple choice exam and a little piece of paper to write my answers on, 1C, 2B, and so forth. For 20 minutes, it was silent, and I didn't think much of it. First of all, I couldn't answer the questions, and secondly, I'm not a big believer in multiple choice, and thirdly, why was I there? But then after 20 minutes, the professor picked up those little pieces of paper. That was 50% of the exam credit. And then put on the table one of these if-at scratch cards, 1 per table. As you see, there are rows 1, 2, 3, 4, 5, and columns A, B, C, D. And the correct answers have been pre-coded with a little star behind that paint that you scratch off like on a lottery card. So what happened was the students at my table said, as soon as they started, first they appointed a scratcher, and then they said, well, 1 was a pretty easy question. I got C. Did you also have C? Yeah, everybody had C? I'll scratch C. They scratch C. There's a star. They go, yes, we got the right answer. But then it became interesting. For 2, there's a disagreement. Some had A, others had B. you cannot scratch off both for full credit, so you have to decide. So the A's were trying to convince the B's were trying to convince the A's, and all of a sudden, they started talking like scientists. And there were aha moments. Oh, yes, remember, the professor said this or that in class. Let's scratch B. They scratch no star. But you can scratch a second time for half credit. If it's still wrong, you can scratch a third time for 1/4 of the credit. So in row 2, they've uncovered 2, they get 2 points. In row 4, they've uncovered 3, you get 1 point. I was really excited because, you see, by the time the exam was over, the students walked away. They had gotten feedback on their learning. It was been fun. They had actually learned during the exam. They had gone, oh, yes, now I get it. And best of all, there was no grading. It's all done. This was many years ago, and I did not implement it because of my dislike of multiple choice. But in this past 2 years, we've implemented it on the computer. So students can now answer any type of questions, symbolic, graphical, text, you name it. So they sit at tables, and they first answer the questions individually, and then, this is from actually a math class, not my own class. Here it says, what is the derivative of function of x equals 3x squared minus 6x? Brian has entered 6x minus 6, Brent 6x, Beth 6x minus 6, and so on. So in the team round, rather than using a scratch card, the students get to see on their screen how all the other students have answered. Now they have to argue with each other, decide which is the right answer. Maybe none of them is right. And then answer gets graded instantly, and there's feedback. Let me show you a little clip from my own class. So the individual round is not very different from a standard examination. They're sitting there and, let's move it closer, and looking at their screen, calculating, and entering the answer. So that's not very different. But then I press the button and we start the team round.
But is this one? Yeah. So I'm going to say B. It's across that's good. Number 13.
Who does? I did. Oh, jeez. I wrote for 5. I said it in DL, and she was like 3, 2,
and E would make the magnetic field coming out of the cord. And so that would be thumb. So it'd be thumb cross.
So, in fact, if you were to walk into my class during one of these assessments, you'd be really surprised if I told you it was an assessment. And you actually saw smiles on the faces of my student. So that's one. Secondly, I think we should focus on feedback, not ranking. After all, isn't objective ranking a complete myth? Can't we all think of many people who had stellar transcript and ended up not performing, and people who had no transcript or terrible transcripts and ended up being stellar? In fact, for this talk, I did something which I'd always wanted to do but never got to do. I decided to go back to data I'd obtained a long time ago and plot 2 metrics in the sense of evaluating students, then plot one versus the other. On the vertical is the final grade, which is based on the final exam. In that year, I was using a final exam, 2 midterms, and it was 80% of the grade. So, and the exams were purely textbook problems. That's on the vertical. On the horizontal is a very different metric, a 29-question test of students' understanding of the concept of force, tested purely by words. If you ask graduate students to solve, and faculty to solve the problem, they'll make 1 to 3 or 0 to 3 problems. According to the author of the test, and there's been a lot of research done on this test, anybody who scores 21 or lower is still an Aristotelian thinker, has really not understood the concept of force. But look at the distribution on the vertical. There are some students who ended up almost acing the test, of course others who did very poorly, but there's a huge distribution. If we look at students who score at the highest level on the conceptual understanding, you still see a very broad distribution from a little over 60% to 100%. Let me draw your attention in particular to these two data points. Here's somebody on the left who is still an Aristotelian thinker, has not understood the meaning of Newton's laws, discussed in week 1, but got an A. And on the right is somebody who scored at a level you would expect of somebody who understands the physics, but got a C. Is this objectivity or is this injustice? So I think the idea of being able to rank people is a myth, and we should really focus our assessment much more on feedback than on ranking. Lastly, no, not lastly, because I have one more, we should focus on skills, not content. A big influence in that respect was this book by Grant Wiggins called Understanding by Design. The traditional approach to the course planning is to start with course content. In this course, we're going to cover topic A, topic B, topic C, topic D. Then you start covering these topics, and after a while, you ask yourself, how am I going to assess it? In this case, the course is completely determined by the content. But rather than thinking about the input, we should really think about the output first. What are the desired outcomes? This is the way you would solve a problem in engineering or a problem in business. You want to start at the output end and ask, where do I want to go? What are my desired outcomes? And then, after formulating these outcomes, you ask yourself, how am I going to assess these outcomes? What am I going to accept as evidence that I've actually accomplished these? So assessment is built in from the beginning. And only then do you think about the instructional approach. So in that case, course is defined by the outcomes, by the skills, by what you want your students to be able to do at the end of the course. And the advantage of this approach is it builds assessment in from the beginning. The assessment informs the instructional approach. Lastly, we should resolve this coach-judge conflict because after all, we're here not principally to judge our students. We're here to help our students be the best they can be. I teach a project-based course. It's amazing what my students are doing on these projects. I want to give them all an A. In fact, I think they all deserve an A. So what do I do about that? Well, a colleague from MIT gave me the perfect idea. Use external evaluators. Assign a panel of other people. I can design the rubric, I give to them the rubric, and they are the evaluators. Ideally, a group of people respected by the students. So I'd like to end here, because my time is up, with a call to action, and then to acknowledge someone. First, a call to action. I hope I've convinced you that we really need to rethink our assessment, because I think unless we do so, we will continue to educate the followers of yesterday rather than the leaders of tomorrow. And just as importantly, I think our test will continue to fail to indicate how our students will succeed later in the workplace.